Okay, we are, I believe we're live. Let's double check that this is working. Let's see which platforms. I get this error on X sometimes. Oh, I'm connected now. All right. Yeah, we're live. It's the first stream since yesterday when I took the final MIT exam in linear algebra. That was brutal. I got a 62% on it according to ChatGPT, or a 27% according to the O3 model. I feel like I should probably average those two because the O3 didn't read my handwriting properly on some of them. I think it's got worse image processing than 4.0 actually. At least it takes longer to do the image processing. And when I was looking at it, it had all these Python scripts running and it seemed kind of hectic. But let's go and look at the solutions. The goal for today is I've got about 30 minutes right now, a little bit less. And I just want to go over the solutions to each of these problems and see what I can learn. You know, I'm not done learning linear algebra. Yes, I did my 30-day challenge. It was more like a 3-week challenge and then some semi-studying. And I felt really successful with it. I mean, what I've heard, a 62 is a passing grade on an MIT linear algebra final, basically. I got all these comments, blah, 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 blah. So I want to just go and review this. So each special solution, suppose A is 3 by 4 and AX equals 0 has exactly 2 special solutions. So each special solution tells us, let's review what I got on this. Go to chat, go to chat. So let's see what I got on problem 1. 5 out of 11, yeah. Nine out of 11. I got full credit on part A. So there are 2 free variables. I wrote R as a 3 by 4 matrix with pivots in columns 1 and 2 and free variables in columns 3 and 4 matching this structure. Did I do all that? I hope. So for these special solutions, so the third and fourth variables must be the free variables. I was right that the bottom row is all zeros. Now I multiply Rx1 equals 0 and Rx2 equals 0 to find these. These are just the negatives of the special solutions pivot entries. Aha. So -2, -1. Interesting. Okay. I should maybe write that out just to get the practice in. I maybe won't have time to get through everything today, but this will be a good start to just review what I got off on this final. I'm going to connect my iPad quickly. Go open QuickTime. New movie recording. There we go. All right, my iPad's here now. Make this a little smaller. I don't need this. So on my iPad, I go, so I have 1, 0, 0, 1, 0, 0. And I have these blanks here. And I multiply this by R1 and R2, or X1 and X2, which are 1, 1, 1, 0. And -2, -1, 0, 1. And when I do that, I call these A, B, C, and D. Hope I'm doing this right. This first problem was only 4 points. It was the second problem that I had an issue with. So the null space has n minus r. So number of columns minus r. Yep, 2 dimensions. The special solutions form a basis. The row space has 2 dimensions. It's orthogonal to the null space. So I need to pick 2 linearly independent vectors that are orthogonal to x1 and x2 to form a basis. This is interesting. So let me read through this, make sure I'm getting this right. Column space has r equals 2 dimensions. Yeah. The left null space has I see. The row space has r equals 2 dimensions. It's orthogonal to the null space, yeah. So I pick 2 linearly independent vectors orthogonal to x1 and x2 to form the basis. The left null space has 1 dimension. Why did O3 give me so many points off on this one? I'm curious. I got the last ones wrong. So, oh, why is it on number? Oh, this is the wrong thing here. Whoops. So the left null space has m minus r. M minus r, that's the reason. Okay, it's orthogonal to C of A. That one's tricky, that second one, but I should review it later. I should ask ChatGPT for alternate versions of these problems or deeper explanations. Let's look at number 2. We're just kind of skimming these right now. Find the inverse of a 3x3 upper triangular matrix with non-zero entries A, B, C, D, E, F. You could use cofactors in the formula or whatever. So by elimination, yeah, they did the same method I did. I just made that careless error. By cofactors, take the minor, then checkerboard. The signs to get the cofactor matrix, then checkerboard. What does part B say? Suppose the columns of U are eigenvectors of matrix A. Show that A is also upper triangular. We have a complete set of eigenvectors for A, so we can diagonalize A equals that. We know that U is upper triangular, and so is the diagonal matrix. And we've just shown that the inverse of U is upper triangular, so their product is also upper triangular. That's an interesting solution. Okay, so basically because I find the inverse that's upper triangular, I get this, and the diagonal matrix is. So it's all about diagonalization, which I never fully got down. Explain why this U cannot be the same matrix as the first factor in the singular value decomposition. The columns aren't orthogonal. For example, the dot product is AB, which is non-zero because we're assuming all entries are non-zero. Okay, cool. So that's why it can't be this. What is the stuff in the singular value decomposition formula? I forget, but I should go over that another time. What did I do on number 2 with them? Man, they were harsh on me. I did better at the beginning of the test. It looks like I kind of just lost steam towards the end. So looking at this next one, number 3. by elimination. We keep track of the elimination matrix. Okay. So number 3 asks, oh wait, that was number 2. A and B are any matrices with the same number of rows. What can you say, and explain why it's true, about the comparison of the rank of A with the rank of the block matrix AB? All you can say is that the rank of A is less than or equal to the rank of AB. Yeah. I think I said all this. So I got 3 out of 3 on both part of the first 2 parts. How did this one grade me for that one? Problem 2, I got 9 out of 11 also. Main issues are orthogonality, not about zeros in upper corner. Okay. Problem 3. I got full credit, partial credit, no credit. Oh yeah, that was the annoying one where I got no credit. If b equals a squared, now rank of a equals a squared. Every column of a is a linear combination of the columns of a. So for instance, if we call a's first column a1, then a1 is the first column of a squared. So there are no new pivot columns in the a squared part of a squared. Okay, let me see if I can make sense of that. How do those ranks? The rank of a is the rank of a, b. A's first column is a1, then a1 is the first column of a. So there are no new pivot columns. That's the point in the a squared part. I think I basically understood that. I just didn't explain well. So I got 2 out of 3. I mean, that's harsh, but fair. And the null space is n minus r, as always. So it only has that. 2n minus r. Yeah, that's pretty straightforward. Problem 3, I could have fully gotten 100% on. Problem 4. Suppose A is a 5 by 3 matrix and AX is never 0, except when X is the 0 vector. You can say that the columns are linearly independent. Did I get that right? Did they give me some partial credit for that? Yeah. So columns of A must not cross through origin. 3 columns and 5 rows. There are more equations than variables. Not quite precise. Yeah. Crossing the origin isn't the key issue. It's linear independence. The columns are linearly independent. The transpose of A times A is never 0 because AX is never 0. Then the transpose of the vector times the transpose of matrix A times matrix A times... Your intuition is mostly right, but a little messy. The key idea, so I should read what they say here. This is the squared length of AX. The only way it can be 0 is if AX has 0 length. Yeah, that's kind of a simpler solution. ATA's B is this. Is a one-time inverse. It's a left inverse. Yeah, magnitude of AX squared is the clearest reason. So I did well on that. What did they grade me off on this one for? 4 out of 12. That's so harsh. 2 out of 5. Yeah, that's messed up. Honestly, I like 4.0's grading better so far. I didn't screw this up as badly as I thought. So the first half of the test I was getting in like around a B, like in the 80%. I really just lost steam. So let's look at number 5 now. 4C. It's the 3x3 identity matrix. It's not because AB is a 5x5 matrix, but only have rank 3. This is part C is a bit confusing, so I should go over that. Okay, number 5. If A is a 3x3 symmetric positive definite, so I need to see how they computed these things. So they said C1 Q1T plus C2 Q2T plus C3 Q3T plus C1 AQ1. So just this messy algebra. C1 squared, I guess Q1T times Q1 cancels out is the key thing. What did I say for this one again? I said something with those values squared. Wow, I have great intuition. Part B, look at the ratio in part A divided by this in part A. Let's see, would make the ratio as large as possible. When C1 and C2 are 0, so x equals C3 Q3 is a multiple of the eigenvector Q3 at the largest eigenvalue. Again, my intuition was right. Notice that the maximum value of this Rayleigh quotient is the largest eigenvalue itself. So another way of finding eigenvectors, maximize this. Yeah, I never learned the Rayleigh quotient. This is another way of finding eigenvectors. Okay, I never knew that. Interesting. Number 6. Find a linear combination of the linearly independent vectors v and u that is perpendicular to u. Wow, really? I just have to write this? That's so annoying. I just wasn't given enough stuff on this one. Oh, that's harsh. Oh, regrading and I got worse. That's tough. Number 6. 0, 2, and 2. So I did something with projections. A linear combination of v and u that is perpendicular to u just means that v dot u, w equals 0u plus 0v equals 0. That's perpendicular to everything, but a more useful choice is to subtract off just enough u so that w equals v minus cu is perpendicular to u. That means u 0 equals, man, this is a lot. W transposed u equals, all the transpose things, they never really talked about transpose matrices. They just started mentioning them towards the end of the unit, and that was a big mess up, I think. WTU equals VTU minus CUTU. So C equals VTU over UTU. Yeah, I need to understand each of those steps. I should jot down which of these I'm totally confused on. So it was 6A. I'm going to actually type these somewhere else. Maybe in drafts here. MIT test 6A. 5B. Which other ones? 5A, comma B, honestly. 4, I actually get it. Oh no, it was 4C. And then number 2, 2C. I should do 1B a bit more. I'll write 1B. basically the whole test. I have to understand better. Let's keep going here. We were on number 6. So let's take a look here. Find a linear combination of u of w. So it's just this. We already know v and w are u and w are orthogonal. Just normalize them. Take q1 equals u over u lambda and solve for the columns r1, r2 of r. qr1 equals u. So r1 equals the magnitude of u, 0, and qr2 equals v. So it's cuv. Yeah, 6b2. Find a projection matrix onto the plane spanned by. Yeah, that's one I don't get. The QR decomposition, I didn't get. It's the SVU or whatever decomposition, QR decompositions that are really tricky. All right, number 7, find the eigenvalues of these. Those are both permutation matrices. What are their inverses? So find the eigenvalues of these matrices. How did I do on number 7? Not bad. 9 out of 11. So to take the determinant of this, expanded by cofactors, I get lambda to the 4th minus 1 equals 0. I totally got these right. Eigenvalues are plus or minus 1, plus or minus I. Eigenvalues of c squared and lambda squared are just plus or minus 1, 2 of each. Okay. Lambda equals 1, negative 1, I, negative I. The only possibility is just check to see which ones work. Then the eigenvalues of c squared must be plus or minus 1 for any permutation matrix. Inverse of c equals c transposed such that the determinant of c is the product of its eigenvalues. Okay, so for any permutation matrix, their inverses are them themselves. What did I say? I think I probably did a lot more work. I got it right. For them. Interesting. Determinant of C is the product of its eigenvalues, so it's negative 1. Well, they had a different method. Okay, add 1 to every eigenvalue to get C plus I. So it's 0. Add 2 to the eigenvalues of this, or let lambda equals negative 2. 15. So I was super close on that one. And then number 8, let's see. Find the least square solution x hat and the projection P when it's a rectangular matrix with independent columns. Why am I looking at this? I want to look at this. How do you find the best least square solution? So least square solution is ax equals b. Oh yeah, this was easy. P equals ax hat equals that. Wow, this was actually easy. That's embarrassing. Oh boy, okay. I should screenshot that. I'll do it later. That's worth reviewing. 8A. How many points did I get off on 8? Yeah, I got part B correct. Let's see what part B was again. Projection is in which fundamental subspace? The air vector is in which fundamental subspace? What did O3 say to me on this one? O3 was so harsh. 1 out of 12 for this. 0 out of 11 for number 7 is insane. I literally got most of this right. Least squares projection question. P equals AX is a linear combination of the columns of A, so it's in the column space of A. The arrows are orthogonal, so it's in the left null space. What did I say my answer? Is it not loading? I didn't say left null space, that's the issue. Find the projection matrix P onto the column space of a specific A. How do they do that? I do P equals this whole thing. Since ATA is that, its inverse is that. It's 1/10 of the identity matrix. So P is 1/10 of this whole thing. Man, that is confusing. I'm going to put 8C there. And we're wrapping this up shortly. I have to run in a minute. So number 9. This question is about the matrices with 3 on the main diagonal. What are the determinants? Did I get points off on this one? Let's see, number 9. Correct. Mostly correct. Calculation consistent, but based on wrong recursion. Yeah, that a lot of teachers wouldn't punish you for that. But basically, the way they want to solve it is the determinant is easy. The determinant is easy. An n-dimensional matrix is 3 and -2. That's easy. The trace of that matrix is A equals 3, and the determinant is -b2. So I literally just did a mental math error there that cost me several points. How many points did it cost me on this one? Let's look at this. Problem number 9, I got, yeah, so 3. I cost myself at least 8 points. So interesting, good review. I'm gonna keep learning this stuff. I'm gonna take a few days off from doing these learning live streams, I think, to do just some whatever the AI thinks will be viral videos, viral live streams. I have some ideas, so stay tuned for those. I'm going to go record my quick short that I post on TikTok and YouTube Shorts, and I will see you guys in the next one. Peace.